Well, good evening. Welcome to Space Oddities. Thank you for joining us on this Tuesday evening. Daz, you may need to set the, you'll have to set the thing up again. We're going to be bringing you very shortly live coverage of the launch of the Ariane 6 rocket, Europe's brand new rocket, on its first flight this evening. Hopefully it's going to be successful. And we're going to bring you that and then go straight into our normal program. As you can see, there's not much happening at the moment, but there's it's meant to launch in about 5 minutes, but it doesn't look like they're going to be doing that. So, Michael, would you like to give us a bit of background on the mission?
Yes, I will. I need to reset my. Okay.
There we are.
I don't go back. Okay. This is all about Ariane 5, the forerunner of Ariane 6, of course. Stalwart of spaceflight of the last 2 decades, I believe. One of the most notable launches was the James Webb Space Telescope on Christmas Day in 2021. Absolutely fantastic flight, very accurate flights, which meant that the James Webb did not need its own fuel to get to as much of its own fuel to get to the observing sites at Lagrange Point 2 as it would have done that was planned for. So that was a brilliant flight. If I can go on, can I go on? That's it. Previous rockets from Europe included Ariane 1 to 4, beginning in the early 1980s. Ariane 1 was the first of the European built and controlled rockets. Developed into Ariane 2.
Okay, Michael, we're going to have to stop again. There's no feed to YouTube.
There's no feed.
Okay.
Yeah, I thought it was. I thought
No,
it was mine.
there's nothing there.
There's nothing.
Error occurred. Try again. Right.
Oh dear.
Oh.
You're going to get a lot of practice, Michael. That's good.
Yeah.
Clean up.
Let me just check something.
Oh dear.
There's nothing there, but then when you actually look on the link I've posted to YouTube, there is an 8-minute segment, and then it stops when we stop. But I don't know why it's not showing live.
Well, it says it's live on YouTube here.
Because now the link I posted, it shows our first 8 minutes. It's like here playing, but it didn't show on the live feed at the time.
Yep, it's fine on YouTube. Let's carry on, Michael. Carry on.
Yeah. Okay. Right. So as I was saying, Ariane 1 was introduced in early 1980s. An excellent worker, sending satellites into orbit from French Guiana. Developed into Ariane 2 from 1983. Ariane 3, more powerful rocket later on in that decade. Ariane 4 was a much more developed rocket, which was able to take a lot more payload into orbit and into geostationary.
Carry on.
Yeah, sorry. Yeah, into geostationary orbit. Then we had the wonderful Ariane 5 from the early 2000s to actually send satellites into geostationary orbit, and absolutely wonderful career it's had as well. So just about Ariane 5. Originally, one of the proposed jobs for Ariane 5 was to fly the Hermes space plane, the Europe side answer to the space shuttle, to actually fly astronauts to the ISS. So very early on, without any development taking place. But Ariane 5 did take up the automated transfer vehicle, quite a number of flights to actually resupply the ISS with cargo and etc. to the astronauts on board. Different variations again of Ariane 5, getting more powerful each time. And depending on payload as well, the ones on the right able to carry bigger payloads again into geostationary transfer orbit. The ECA version was quite popular, and it launched 84 times between 2000, since 2002, and exclusively from 2019. So it's one of the launches from French Guiana. This is the James Webb on Christmas Day in 2021. And another one was, I understand, was the JUICE interplanetary probe from Europe to the icy moons of Jupiter. Okay, so coming on to Ariane 6, this is a recent picture of Ariane 6 on the launch pad. A slightly sleeker design, I think. It's shown on tonight's launch, is shown with 2 strap-on boosters. I understand that it might take 4 strap-on boosters for extra payload, according to this diagram here. So we've got different different strap-on boosters for different payloads. Again, one thing of note as well, though, is Ariane 6, although, as Andy said, it wants to take on the market from SpaceX, Ariane 6 has not been designed to be reusable. So it's still a throwaway, use once rocket, unfortunately. But it's another story. This is just a quick diagram showing the stages of the ascent into orbit. After a couple of minutes, the solid rocket boosters fall away. Then we carry on, engine burn, and then coast for a short while, payload separation, and then the second stage and payload are get the satellite into the orbit required. And this is the booster that sends the payload into the correct transfer orbit that's required. This is the payload that's on tonight's flight. A few different small satellites from various organisations. So it's quite a big payload, really, made up of different contributions.
Right, Michael.
Yeah.
Let me just check something. I think it's already launched.
Yeah, yeah, and they've had the separation already.
Oh,
The booster rockets.
Oh dear. I mean, this is right. Can you rewind it, please?
I certainly can.
Okay.
If you like to go full screen with it,
we've had
Andy.
a few gremlins this evening, and our timings as a result.
Oh dear. This is what happens with a live feed on watch.
Just trying to find the start of it.
Well, it was about 3 minutes ago.
Yeah, it was on time then, wasn't it?
Yeah.
Right, so let's it's 1 minute to go, so just move on a bit.
Give us some sound.
Stop, I 0 moins 1 minute.
We are 1 minute to launch. Our best wishes to all the Ariane 6 teams, everyone who's been working so hard for today. Good luck, everyone.
Go Ariane 6, gute Reise and bon voyage.
Bon voyage.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage de successor, décollage.
And there it goes.
Yeah, that didn't hang about, did it?
No, no, doesn't hang about, does it?
Doesn't hang around, does it?
It's them solid boosters, isn't it?
Yeah.
That's real time. That's awfully fast for a heavy lift booster like Ariane.
Nominal. Trajectoire nominale.
Nominal trajectory.
Yep.
Europe's new rocket,
Pilotage calme, trajectoire nominale.
Ariane 6, has left the pad and is blazing a trail across the equatorial skies. The range operations manager is telling us that everything is going according to plan. Tina.
And I didn't know my heart can pump so fast. Oh my god.
Oh, look at that. That's no
Trajectoire nominale, pilotage calme.
We're rumbling now. And Jupiter too. We hear her.
It's quite exciting.
Oh, she's coming, she's coming. Oh my gosh. This is happening.
It's the most incredible feeling. We have we're tears here in the commentary box because this is a big day and a big moment.
Europe is back into space.
The buildings are rumbling around us now.
Yeah. Well done.
And look, these are
Well done to everybody involved.
Yeah. Let's just hope this one's as successful as the Ariane 5. I think it was. I think altogether it had was 100 and was it 17
Boosters
flights?
are doing all the work.
Yeah.
Yeah, and it had 2 fails and 2 partial fails.
Yeah.
So it's been very successful, and this looks really nice.
We might even be
C'est
able
nominal,
to see
trajectoire
this.
Beautiful.
We have skies tonight, this afternoon. We had rain all day, but the clouds parted. The 2 dots there, the boosters.
There we see them falling off.
There we are.
Separation.
Confirmed. We have booster
Yeah.
separation.
That works.
So, wow, that's the first clapping here that we see. What a beautiful liftoff.
Look at that shot. Isn't that amazing?
On board.
The boosters are still attached as well.
nominale.
These pictures are
I presume the boosters are non-reusable.
Everything
Yeah.
is not. Wow.
Yeah.
Amazing, amazing. So
And
these
that's,
boosters, they have
I mean,
transported
with
us
being
60
unreusable, that's one of the
kilometers
failures of it, unfortunately.
And
Yeah.
you see that dot
It,
is the
Nominale.
telling
but
us
we're
that
especially
everything
with-
is normal, everything going according to
I
plan.
mean, they'll be using
Engine on the main stage that you can see
hopefully
there,
they'll be
and we've got
looking
a
at
camera inside now. What are we
reusability.
looking at here?
Michael, you were
It's back
talking
down the
about
earth.
that it was
This
going
was
to
actually
have
the camera inside the
sort of like a
interstage,
space
so we'll
plane on
be
it. Was
able
that
to
the
see when the
Nemesis?
lower stage separates.
Hermes.
That's coming.
Hermes.
Hermes.
But now we've
Hermes
actually
was it?
lost half our
Yeah.
mass already.
Yeah, because I know the
Boosters
Ariane
have
5
burned
was
almost 300 tons of fuel in
crew
2 minutes.
rated, so
Yes.
Nominale.
Yeah, unfortunately.
Nominal.
And we're
As the
getting
range manager says.
True, unfortunately.
yes, and we're getting close now to the next thing, which will be the jettisoning of fairing. The fairing being the nose cone of the launch vehicle, which is where the passengers are sitting. Oh,
Séparation de la coiffe.
You even see the wow. That's amazing.
The problem is, of course, that because the rocket isn't usable,
Our
it's going to
confirmation that
be
the fairing
substantially
has
more
been jettisoned.
expensive than
Yes, so the
flying
fairing that's protecting our
SpaceX.
spacecraft withstands all the pressure and the heat.
So I wonder how
and,
much of
once
a
we
market
stuck out
they
the
will
nose out of the
be.
atmosphere, we didn't turn
exactly.
anymore. And it has
The
been
cost
jettisoned.
of
So
a
what we're
launch
looking at now is the main stage,
for an
which is what
Ariane
we're
5 was between
on the right hand of
150
the
and
screen.
200
Yes, and
million
this is the live
euros.
camera from
The
orbit,
cost
and we
of
see
launching
the
this one
battery
is,
going up there.
depending
And
upon
taking
which
pictures.
configuration
You
it
see how it
is,
twists,
it's
I believe,
75 million or 115 million euros.
Nominale.
Exactly. And we also see on the screen.
Whereas I
outside
think the
actually
current
the
cost of
telemetry
launching on a
set.
Falcon
You see
9
the
is about
trajectory.
29 or 30 million.
Yeah.
So in
Yeah,
green,
again, this
time
comes back to the
trajectory, and in yellow,
reusability.
the
Yeah.
actual flight trajectory.
Part of it,
everything going
unfortunately.
nominal. So you have altitude over time.
Looking at
And
that
in the middle you see our ground
screen,
track. You see exactly
and
where we
that's
are
the
over the
path
Earth.
is
And
quite
on the
high
right side you see our
elevation.
altitude. We're already in 140
Yeah.
kilometers
Yeah, we should point out that the view on the right is a simulation. It's not.
Oh, yes.
kilometers per
Good,
second, and the main stage is
an alien view.
operating.
So the fairing has been
You can see it's a
ejected.
great big
We're
tank
now looking at the
of
simulation,
fuel.
obviously.
Indeed. So it is a 32-meter high
So the next
cylinder.
stage up is
with
booster
23 tons
separation.
when it's empty, and it can carry 154 tons of cryogenic propellant, supporting the upper stage and the boosters. For our technical audience, we don't have any common bulkhead anymore, so we have now 2 separate tanks. And this makes the handling of the pressures a bit easier than on Ariane 5.
It's burning a very powerful
Propulsion
engine.
nominale, trajectoire conforme à l'attendu.
And don't forget, viewers, the European spaceport is in French Guiana in South America. That's where we
mainly for
launched
cost
from
reduction
today.
reasons with regard to
A really good position for
manufacturing is
putting
completely
spacecraft
different, and
into
the generator
equatorial orbit,
side of
because it's more or less on the
manufacturing.
equator.
Yeah, a lot less severe closer than Kennedy Space Center is.
Yeah, absolutely.
And you get maximum boost from the Earth's rotation.
Yes, indeed.
They're actually so high that the thermal protection around the nozzle.
Yeah, because they were talking about the engines. The first stage uses a Vulcane 2.1 engine, which is hydrogen and liquid oxygen. And it's an updated version of the Vulcane 2. Of course, we had these solid rocket boosters, and there can either be 2 or 4 of them. And the second stage uses a Vinci VINCI engine, and again that's hydrogen and liquid oxygen propellants.
Separation is done by the guidance algorithm, and afterwards the Vulcan engine is cut off, and 6 seconds
Well,
later,
they all appear to
we
have
will
worked
see
well
the
today.
separation of the stage,
Yeah.
initiated by pyro commands, and we do that by actually extending a set of springs. And the push that the lower stage does to get rid of the upper stage, or the other way around, push itself away from the upper
So
stage.
the Vulcane
has the same
2.1.
there we are. We have a live
as
here.
we call it, as the Vinci engine, but it only does that during 0.2 seconds.
Yeah, we got the Vinci engines coming on for the second stage.
Is that related to Da Vinci, I take it?
Getting close now.
Yeah.
Go.
Yeah, he painted it.
That's coming up in a few seconds.
I hope that's a delay because it says it's already separated. But
Fin de mission garde.
Tell us that the safety mission here, the Space Center, is now finished.
dogs in space by the sounds of it.
Extinction du moteur Vulcain.
We have confirmation that Vulcan has switched off.
Séparation de
There
l'LPM.
we are.
And
Okay.
Had
the
separation.
has separated, so he gets
Oh,
these
so
informations.
that view we had
Before
must have
he
been
gets
a
on the screen.
camera that was on the booster stage.
Allumage du moteur
Yeah.
Vinci.
And Vinci
Well done.
started.
Well, well done,
That's a
ESA.
Very, very, very important
Well
one for
done,
this mission.
ESA. Anybody know how long till the first payload
And we have
launch?
applause here.
Clapping here in Jupiter.
No, they haven't got. They've got the
Happy
scale
faces.
along the bottom, but there's
The
no
upper
time.
stage.
See the lower stage
Propulsion
falling off.
nominale.
There we go.
Oh, propellers.
Look at that.
Wow.
All a bit scorched on the
Wow.
side.
Will we see the Vinci
Probably from the
engine also
booster return.
Yeah,
firing?
that'll need a lick of
I don't
paint
know
once
if
they
if that
dig it
camera's
out
on
the ocean.
camera.
Which they won't do, of course.
This is
No, of course
really
not,
something.
no.
Carry it. Look. You see the
So you can
collision
see
here on
the
Vinci engine?
Vinci engine
As
start.
it's
You can
heating
see
up.
it turning scarlet.
Beautiful.
the nozzle.
And you can see that we're actually up there right now.
And the curve of the Earth for our
So
flat
you can
earthers.
see that we lifted off
Yeah.
from our pad here at the Guiana Space
Ah, that's a
Centre.
fisheye
We
lens.
increased our altitude
Propulsion
to
est nominale.
That's the edge of the disc.
Oh, he's helping
We're
out,
really
Roger.
going to second
Thanks.
propulsion. Well, and look at that, Tina, the curvature of the Earth with the Vinci engine burning away.
Allumage APU.
And here we hear calling out that the APU, a new feature actually on the Vinci, on the upper stage of Ariane 6, has also switched on. So there's a lot of good news coming in here, because the big innovation actually of Ariane 6 is, of course, the reignitable Vinci engine. It can switch on and switch off, and it does that by the help of the APU.
Pilotage
We will
calme.
talk more about the
Propulsion
APU later.
nominale.
So both are running.
Oh,
as
look,
planned.
look.
Wow.
The globe Earth.
Yep.
We are now in our first.
And she said the Vinci engine is designed to relight several times
reignite the Vinci
in
engine
space.
twice
So
in this mission. big shout out here for the Franco-German cooperation. The upper stage is designed and built by Ariane Group in Bremen in Germany, and the engine was designed in Vernois in France, and the whole stage has been put under test in Lamprothhausen on a brand new test bench designed by the German space agency, the DLR.
And then shipped over to
that's an immense effort, immense team effort to get this
get the stiff neck here.
So we're going to be very happy.
Yeah, trying to
off the ground.
like an owl
Let's
twist
take a
so
little
you can
look
keep
now
it.
at
Yeah.
what's coming up for Europe's launches in the future.
There we go.
Well, there we are. Okay.
Hey.
So I think we leave it
Right.
there, yeah?
We are
Yes.
already working with our
Okay.
partners.
So, there we are. Europe is back in space with the Ariane 6 rocket. Many congratulations to Europe for the successful, so far, maiden flight of the Ariane 6, replacing, as we said earlier, the venerable Ariane 5, which carried out a total of 117 successful launches with only a couple of failures. And, as I said earlier, Europe hopes to compete with the likes of SpaceX for the satellite launch market. But as we also said, because it's not a reusable rocket, launches will be significantly more expensive. So it remains to be seen how Europe does in that market. There will be some demand for it, but I have a feeling the lion's share of the satellite market belongs to SpaceX and is likely to do so for the foreseeable future.
Yeah.
Anyway, big apologies tonight for our technical gremlins, folks. We had a few false starts because we had some technical issues here, but we appear to have overcome them now. So thank you all very much for joining us on this Tuesday evening. And we've got the usual suspects. I don't think they need any introduction, so I won't. But joining us this evening after a long absence, far too long, is Rachel. So lovely to have you back with us, Rachel. Lovely to see you. Hope everything's okay. How is little Isaac?
Yeah, he's doing good. He's 1 now, so he's toddling around and like a chaotic, small, cute tornado.
Is he walking yet?
He can walk, sort of holding one hand now, but he's still leaning. He can walk with a walker and things, but not independently yet. But he can crawl like the wind. So.
He's over a year old now, isn't he, Rachel?
Yeah.
Yeah. It's worrying. We're having to declutter the whole house now, which is very stressful.
That's what I was going to say. Everything's got to be at least 3 foot high.
Every 4 seconds, it's, what have you got in your mouth? Give it to mummy. Put it down. Stop. And he's just constantly crawling around going.
He's exploring.
Yeah.
Just reminded me of how dirty my house is and how much more I need to hoover.
Yeah, the thing is, give him 2 more months and he can do a paper round, so he can earn his keep there.
He'll have a great immune system there.
Well, yeah, that's what you got to build it up. Yeah, wait until he gets in the garden digging up worms.
When he's chewing on a slug, and then I'll be worried.
Yeah,
slugs are great. All right. So anyway, glad to have you back with us, Rachel, and hope you'll stick around for at least some of today's show. We understand that you have mother type things to attend to, probably. So there we are.
I'll do my best.
Okay. Well, thank you for your time, and thanks for being here. Thank you, viewers, as well. Thank you so much. Thank you to those of you rather, who are continuing to donate very kindly to Space Oddities and buy us coffees and other stuff. And don't forget, if you would like to help us keep the show on the road, you have the super chat icon underneath the chat window. You can buy us a coffee, and if you want to buy us a coffee, I will tell you exactly how to go about that, because you can just scan this QR code that has just appeared on the screen, and there's a link to it in the chat as well. And any coffee is gratefully received. As I always say, all the money goes towards paying our bills here at Space Oddities, and that's where it goes. So if you'd like to see us continue, your support is always gratefully appreciated. So what else? Well, we've got the Space Oddities summer merchandise, of course. Now's a fantastic time to buy, because you can buy your Space Oddities 2024 summer collection t-shirt that Michael is kindly modeling for us this evening. There we are. It is actually exactly like that. It's a good quality t-shirt, available for £20, including UK postage and packing. Scan the code, click the link in the chat, And jolly good they are.
Confirm that it does wash well.
Yeah, unlike you. So we have also the Space Oddities hoodies available in black. These are, for those cool summer nights, which I know you get a lot of in the UK. I've never had the opportunity to wear it here, of course. It's too warm because we've got 34 degrees here, something like that today. It's going up to 37 or 38 later in the week. So I'd be glad to not wear anything, to be quite honest, but I might shock the neighbours. So there's the hoodie. You can have the t-shirt, by the way, in a long sleeve version if you pay an extra £3. The hoodies are £40, including UK postage and packing. And if you're ordering from outside the UK, please add £10 to the total value of your order to cover the postage and packing. All of the merchandise is available at the Space Oddities shop. And I will just put that up there so you can have a browse there. The old design of the Space Oddities t-shirt and hoodies are there, plus the new summer designs, and you can browse that to your heart's content. So thank you very much indeed for that. Okay, well, moving on. I think it's time, as time and honour dictate, that we move over to finding out what's up in the night sky at the moment. So, Roger, what have you got for us this week?
Well, we will be seeing in a moment. So let's have a look. So we're coming up through to the middle of July already. And we've just gone past new moon over towards the weekend, which will have its first quarter. And during Thursday, you might be, or Friday even, we might be able to see the Lunar V and the Lunar X. So I'm just pointing it out to where it will be for those for the 13th. And the V is up on the upper part of the moon. And the Lunar X is just down below. And they both, well, the V will appear slightly an hour or so ahead of the Lunar X, but they both will be visible during that time. And just to give you a location there again. But if you want to see any other Clara Obscura, there is this one, which I call the Hitchcock profile. And, at a certain angle, you get a profile of a face there due to the nature of the mountains casting its shadow, and that is available for a few hours as well, and that may be of interest. Although it is a small feature, it might be a bit smaller than the Lunar X and the Lunar V, but always interesting to find these various things. And unfortunately, I haven't seen the sun for a few days. So this was what it was on Independence Day in White Night and HA. Still getting a little bit of activity on the go, but it's died down a little bit, although there were some rather interesting prominences over on the eastern limb there. I've just about caught the tail end of it, but there was a good seeing of it. And this is for the at midnight from this week, and we obviously got the dominating summer triangle on view, and the down in Sagittarius, where we've got the heart of the bright core of the Milky Way to see. During the just before sunrise, we've got Mars and Jupiter coming up, and we've got Venus and Mercury trailing down behind. So when you do get sunset, Venus and Mercury will be in the evening skies. And of course, being fairly close to the sun, it's still not brilliantly clear, but Venus has got a better chance of being visible than Mercury. But tonight it was at its highest point in the sky for visibility, but the traditional English summer weather has eluded us that spectacle with all this cloud and bad weather. But as we get through the week, they are becoming slightly more apparent, but it will take a little bit of time to be carefully seen on the low western horizon. If you're still interested in comet watching, we've got Comet Obers, which is going down below Ursa Major. It's still reasonably bright, although we still have some issues with the sky still being a bit bright. And as we go through to August, it has now will fade to about a magnitude 7. So it's now past its best, unfortunately. But Schunensen Atlas is still with us and still gradually brightening up. It's down below Leo at the moment, and is still producing a bit of a tail, although that will obviously become much more apparent as it gets closer to us during September. And as you can see, from the 9th of July, it's magnitude 9, and on the 2nd of August, it's down to magnitude 7.9. So it is starting to brighten up rather.
We're out of the 8s at long last.
Yes, we're getting there. We do have an image from the web.
Yes.
This one is showing a protostar, which is roughly 460 light years from Earth in the constellation of Taurus. The more diffuse blue light is the filamentary structures of the image comes from organic compounds known as polycyclic aromatic hydrocarbons, TAHs, while the red at the center of this image is an energized thick layer of gases and dust that surround the protostar.
Look at that. A baby star.
A little tiny baby star. Lovely.
Fantastic.
Being born.
And now for some lovely images from our subscribers. And we've got another interesting one from Andy Weller of Mellet 15, which is one that Rachel and Johnny like to take a picture of. This is 4 hours with an Edge HD with a 0.7 reducer on it. And this is what he's produced.
Look at that.
Ooh.
Well done, Andy. Look at that. Isn't that fantastic?
Oh, wow.
That's gorgeous.
Who needs the Hubble?
Well, exactly.
Or even the web.
Hubble Schmubble.
Yeah, lovely jubbly. Very nice.
That's very nice. Yeah, lovely.
Right. And we've had some from Sonia. We've got a halo, summer halo, which was done on.
Oh, nice.
I can see all the vapor trails going across the sky as well.
Yeah.
And very nice.
Well done, Sonia.
Yep. And she's also done with her drone the Belt of Venus, which was done on Sunday. That's come out rather clear as well.
Ooh, lovely colours.
Yes, very nice. She's obviously utilising the drone quite well to get these interesting aerial shots that might be somewhat abstracted. So well done to Sonia.
Yeah, very nice.
Very nice.
And then she managed to get a picture of a very thin moon at the weekend.
Oh,
that's nice.
Oh, that's
Look at
nice.
that.
That is very nice.
Now, by my reckoning, the picture on the left, just above the roof line or thereabouts, will be Mercury. So it would be roughly at about a 7 o'clock position, roughly about level with the top of the roof there. But
well, in fact, if you look at the right-hand image, see where the antennae are on the right. If you look just below that, you can't see it.
I know. You silly bugger. Anyway,
there's always one.
It's still a nice clear image of a very thin moon, which she was fortunately to witness without any clouds obstructing. And one from Lee here of the Great Rift Summer Triangle area. Now this was done with his Canon and Samyang lens, which was on a tracker. So be looking at this. Look at that.
Oh, wow.
Wow.
And he's managed to get some of the red hydrogen of the North American nebula there as well. if you look at the where the dark area almost stops, you'll see the North American Nebula there as well. So
well done, Lee.
he's managed to pick up some of the hydrogen reds there as well. So he's done very well there.
That's fantastic, Lee.
Good. Very impressed. Very good. And that's what we have for this week.
Thank you very much, Roger.
That was very good. Lovely images. Lovely images.
Yeah. See, I didn't put any in the gallery this week.
Yeah, we had noticed. We didn't want to say anything.
Hey, yeah. Hey.
Yes.
This is the latest member of the Space Oddities team. This is Isaac. If you haven't met Isaac before, hello, Isaac. Hi, Isaac. Hello, Isaac. Hello. Say hello, Isaac.
No, not
Daddy's watching the football, so.
Who's winning?
Spain.
Spain
are 1-0 apparently, thanks to Kevin.
Oh, fantastic. Hello, Isaac. Hi. Oh, he's gorgeous. He looks stoned.
Well, he was asleep, but he's woken up.
It's probably something he found on the floor. Some of Johnny's, no doubt.
Could be anything.
Yeah. Anyway, thank you all for the images. Keep them coming in. If you would like to see your image in our weekly gallery, then please email them to spaceodditieslive@gmail.com. 1 image per email, please. Put the word gallery somewhere in the subject of your email so that it can be picked up automatically. And thank you very much. And if you could include a few details about how you took the image and exposure details and equipment, all sorts of stuff like that. You know how it goes. But it'd be nice to have maybe some people who haven't sent in images before. Don't be discouraged. We're looking for any astronomical images, any skylines, any evening skies with trees and water and ducks and things. Anything basically you think might go down well with our viewers here. Don't be frightened. Do send them in. spaceodditieslive@gmail.com being the address. And Ian says we don't care about footy. Quite right, Ian. We don't. So there we are. Right. So well, I think we'll move on. I think we'll move on now to the news. Been a few things obviously in the news this week. So let's just sort this out here. And I'll be with you in one second. Just need to get this going. There we are. Okay. So this is the news for this week. And we have a few things to look at. Firstly, you may remember the DART mission. Panel, quick resume of the DART mission for the viewers.
It was to smash things up.
Yeah,
it was to deflect an asteroid.
Correct.
Moon of an asteroid, actually.
A moon of an asteroid.
Yes.
Yes.
It's also another moon.
And why did they do that?
To save our butts.
Exactly.
Yeah. It's to see if it's possible to deflect using a ballistic missile. Well, not missile, but ballistic item to nudge it out to move its trajectories. If anything's coming towards us, it would move it away. If we can catch it early enough, move it by possibly a fraction of a degree, so that when it gets to us, it's going to miss us by miles. So.
Absolutely. And
now that Bruce Willis can't help us anymore.
No, that's right. He's getting too old for that sort of stuff now. And anyway, I think perhaps somebody will correct me if I'm wrong. I think they managed to change the orbit of the asteroid by 23 seconds, if I remember rightly.
Yeah, something like that. Yes.
Yes.
So that not only tells you about the effectiveness of the mission, but it also gives you some sense of the composition of the asteroid.
Yeah, that's right. And it didn't really do what we expected it to do, did it? It had some weird effects that we weren't expecting, and it threw off a lot more debris than people thought it was going to. So its composition was obviously much more like a rubble pile than a solid body. But also the way its orbit was changed in its shape as well as its timing was not exactly expected. Anyway, the point of all this is that China is now planning to do something similar, and they plan an asteroid smash as well. This is going to happen sometime before 2030. They are going to smash. You were struggling with the right term, Daz. Technically, it's called an impactor. That is to say, another spacecraft. into an asteroid in exactly the same way that DART did. This is another experiment in planetary defense to work out what we might do in the event of an asteroid that was threatening the Earth. And in this case, they've picked an asteroid which is about 30 meters wide. I won't bore you with the number because it's EX1PHGY74, a catalog number that doesn't mean anything to anybody. But this is the plan before 2030 to impact another asteroid, and this time to see what happens to that one, if there are any similarities with the DART mission, and comparing the two bodies to work out whether this plan of perhaps deflecting an asteroid from hitting the Earth by slamming something into it, to see whether it actually could work with different types of asteroids. Not much is known about the 30-meter asteroid they've chosen, and we will have to wait for more data about that. Now, while we're on the subject of asteroids,
Andy, before you go on, just with this, this sort of like impactor into asteroids. I mean, it seems very strange that all the asteroids we have visited seem to be made of this rubble texture rather than actually anything solid. But isn't there a planned mission to send another probe to this system again to check exactly what's gone on? And didn't I also read somewhere that one of the other probes, it may be Osiris, not the Osiris Rex now, what's it called? Where's it going? Yeah, it's going to another comet anyway, or asteroid. It's going to pass close by, so they're going to try and take photographs as well to try and determine what exactly happened. So
yes, it's a European spacecraft, isn't it? If I remember rightly.
I'm trying to think. I know there's a spacecraft that's on its. They're going to send a spacecraft to leave this system, but there's something that's going to be passing fairly close, and they'll be able to get some more images of the actual. Was the results? So I'll just, you can carry on now. Sorry.
Yeah. While we're on the subject of asteroids, one broke up over the USA last week, over a place called Whittier. I was going to make a joke about it, but I couldn't think of anything wittier to say. Look at this. This is beautiful. At first, they thought it was space debris, but it turned out that it was actually an asteroid breaking up over the USA. So I just thought I'd show you that because let's just have a look at that again.
This was a moderate-sized small body, I think, right? Maybe.
Yes, absolutely.
A bus.
And I'm not sure whether it was one that was known to us or whether this was completely new, that it just came out of the blue, as these things sometimes do. I don't know. There wasn't much information, but fantastic piece of video, I thought. So there we are. Okay, moving on. Congratulations to NASA. The Parker Solar Probe has made another close approach to the Sun. Now, the Parker Solar Probe is on a multi-year mission to investigate the Parker Solar Probe, and it completed its 20th close approach to the Sun on June the 30th, equaling its own record by coming about 4.51 million miles or 7.26 million kilometers from the surface of the Sun. That's close. And this approach, which of course is known as perihelion, its closest approach to the Sun, occurred. Anybody like to guess how fast it was moving when it did that close approach to the Sun?
Probably about 4,000 miles an hour or something.
Bit more than that, 394,736 miles.
Oh, I was so close.
Yeah. Which is moving some, as they say. It checked in with the operators of the mission on July the 2nd. All systems working normally, doesn't appear to have suffered any problems at all. Now, it's going to fly around the Sun at the same distance and speed one more time this year on September the 30th. And then its three final planned closest approach. First of those is going to happen on Christmas Eve this year. Yep. And it's doing a Venus gravity assist on November the 6th. And it will zoom just 3.8 million miles from the solar surface. And at that point, it'll be moving at about 430,000 miles per hour, which will make it by far, I think, the fastest object that humans have ever sent into space. So congratulations to NASA on another perihelion by the Parker Solar Probe.
If I could just make a comment.
Of course.
NASA is working with the Astronomical League and the Johns Hopkins University Applied Physics Laboratory to host a Parker Solar Probe Observing Challenge.
Oh, yeah.
If you go to the Astronomical League's website, you'll find it. And there's an observing component, a solar observing component, as well as an outreach component to teach other people. And if you are successful, you will win, let's see if I can even show this, a commemorative 5-year Parker Solar Probe pin that I just received from Johns Hopkins University. So
wow.
It's running now. So there are a few people who've actually already completed it. So get in on the early end.
So what exactly do you have to do?
There's some solar observing that you have to do. It could be either white light or hydrogen alpha. You have to give some sort of a community program that teaches about the sun and about the Parker Solar Probe mission. Not too difficult, but you do have to satisfy all the requirements, and then you get this very hard to find commemorative PSP pin.
Wow. Oh, thank you for that, Lou. That's great. Well, there we are. Look up the Astronomical League website, and if you'd like to enter and get your own commemorative Parker Solar Probe pin.
Yeah, fantastic. Just as a matter of interest, where was that? I just saw that. Gaza just asked a question. He said, or just pointed something out. Has it come up? No, it doesn't look like it wants to come up. Here it is. Imagine if Voyager was going that speed. In comparison, we're talking about 430,000, what was it, kilometers or miles, Andy?
Miles per hour.
Miles per hour. How does that compare to how fast the Voyager is moving?
Yep. Voyager is moving, both Voyagers are moving approximately, so now we got to do some math, about 3 AU per year. So if an AU is
93 million
100 million miles, just to make it easy, right? So now I have to get my calculator out. 100 times 10 to the 6th million miles per year divided by 365 gives you per day, divided by 24 gives you per hour. So that is only 11,000.
Cool.
That must be more than that.
Miles per hour, something like that.
No, I thought it was about 65.
Well, maybe. Perhaps I've done my math wrong, but our viewers can help us.
Yeah.
3 AU per year. What's that in miles per hour?
Yeah. 3 AU per year, in miles an hour. There you are. Get your calculator out.
But there is, well, basically what we're saying, there's a humongous difference, isn't there?
Oh, yeah.
So, yeah. So that just goes, like I said, it's just sort of like a comparison to what Gaza wanted to know. So, yeah, there you go. Yeah. Thank you.
It's always nice to report on the opening of a new observatory. And this, last month, we saw this happen in Cyprus. This is the new observatory in Cyprus. It's called the Troodos Observatory. It's publicly funded. It costs 1.77 million euros. It's got a very, very interesting design. It looks a bit like a spaceship. And it's hoped that it will encourage visitors to visit increasingly urbanized areas because there's a fund in Greece and Cyprus to develop these remote areas that nobody visits and broaden their celestial knowledge. It's been designed by three siblings, actually, Eleanor, Nicodemus, and Cassandra Sokalis, and they are sci-fi enthusiast architects as well, and they designed the whole building. It wasn't intended to look like a spaceship, but everybody inevitably is saying it looks like a spaceship. That sort of ramp on the left-hand side you can see, that's designed for people to take along their own instruments and do astronomy from there, sort of an observing platform. And Elena Sokalis said what we're trying to replicate is that feeling of wonder, especially for children, to have and the curiosity and yearning to know more about the world beyond the everyday existence that we have. And this observatory, part of this fund I talked about, the EU-backed GeoStars project, to regenerate isolated rural areas in Cyprus and Greece, is equipped with a 20-inch reflector, which is the biggest one on the island of Cyprus. It's a 5.6 meter wide dome, and they've also got a solar telescope in there as well. So congratulations to Cyprus on the inauguration of their new observatory. I wonder how many people remember this. Who can name this vehicle?
Oh, is it? British astronomical people, wasn't it?
No,
nothing. It's not the one I'm thinking of. Then. No.
I know what it is.
Go on, Michael.
It's Skylon.
It's Skylon.
That's the.
Yeah.
Sorry, I was out of the room.
Yeah. Skylon is a British space plane. This picture, that I remember looking at that back in the late 90s.
Yeah.
And I thought it was the sexiest thing I'd ever seen in my life, including my wife. And it's, I mean, look at it. It's pure Thunderbirds, isn't it?
Oh, definitely.
Yeah. And this was what was touted as being the result of a project by a British company called Reaction Engines Limited. And this is what they floated in front of the world. Look, we can do this, because they were developing the engines for it.
Yeah.
And these engines are hypersonic. They're called Sabre. Yeah. But unfortunately, the company has announced they're seeking extra funding after recent poor financial performance of the company, followed by a round of job cuts, sadly.
Oh, right.
Despite this, there is still considerable interest in the company as it pushes forward with the design of the engines that can be used in future space planes. So this originally was not what they were going to build, apparently. This was just, this is what could happen in the future. They were never intending to build the space plane themselves. They were only building the engines. But having said that, Europe's always shown a lot of interest. And in fact, they recently, in 2021, gave Reaction Engines Limited £3.9 million. The project is being backed by Boeing and Rolls-Royce. Rolls-Royce are heavily involved with this. We'll come back to why exactly in a little while. The engines have so far passed successive tests of its hybrid air-breathing rocket engines. And these engines can achieve speeds of Mach 5.5 within the atmosphere with a jet engine and a very special pre-cooled jet engine. And then the rocket engine, the liquid oxygen fueled rocket engine, will kick in and take the speed up to Mach 25 up into space from a closed cycle rocket engine. Now, you may remember back in the early 80s, Rolls-Royce started a project called HOTOL, which was going to be a British space plane. Everybody got really excited about it. But then the government pulled the plug on it and said, no, you're not having any government money. This is too expensive. The chief engineer, the chief architect actually behind the whole thing was a guy called Alan Bond. And he is the head engineer at Reaction Engines Limited. He's a very, very talented, obviously, engineer. And they've done lots of tests with the Sabre in various stages so far. It's all passed. Europe have said they're going to give more money to the project. These days, governments have a little bit of a better attitude towards British space technology. And they have given Reaction Engines Limited some money. But they need more, basically. So they're employing an advisory company called Silverlight to sort of orchestrate the fundraising so that they can carry on with the project, because the Sabre engines are innovative, unique. Nobody else in the world's got anything like them, and they definitely are going to work. So there we are. So I just thought I'd mention that. There's another view of another drawing.
Yeah, I'm sure there's something that the British Space Society or the British Space Agency or something were looking at, which apparently is the oldest space society in the world. continuous.
The Interplanetary Society.
That's yeah. Sorry, that's who I'm thinking of.
Yeah.
They were looking at reviving this a few years back, helping out with the Skyline project. Yeah. Well, we'll look into it. I'm just going to have a look now, actually.
What is the payload for this? Is this human space exploration or
no? It is designed as a satellite launcher. It is designed to carry payloads into LEO.
Okay, so no landing capability.
Oh yes, absolutely. It will land like a plane on a conventional runway.
Okay.
It will take off from a runway and land on a runway.
Yeah.
So it's a really exciting project. So let's hope they can carry on with the development because it's British, for goodness sake. We need things like this.
Yeah.
Okay, let's move on then. Now, NASA have announced that COSY is to launch on a Falcon 9. What is COSY, you may ask? Well, it's a small research satellite designed to study the violent processes behind the creation and destruction of chemical elements. And it's going to launch on a SpaceX Falcon 9 in 2027, and NASA announced this week. The COSY stands for the Compton Spectrometer and Imager, COSI. It features a gamma ray telescope that will scan the sky to study gamma rays emitted by the explosions of massive stars at the end of their lives. And these supernovae, we know, generate reactions that fuse new atomic nuclei in nuclear synthesis, of course, into heavier elements. It's a relatively small spacecraft. It's built by Northrop Grumman, weighs less than a ton, but it is going to ride into space on the top of a Falcon 9. And it's going to do that because it's going to operate in an unusual orbit about 340 miles or 550 kilometers over the equator. And this is an orbit chosen to avoid interference from radiation over the South Atlantic anomaly. Now, this is the region where the inner Van Allen radiation belts come closest to the Earth's surface. So to avoid that, they're going to put it into an equatorial orbit. And it's going to the Falcon 9 is going to take off from Cape Canaveral. It's going to fire its upper stage sort of in a sideways maneuver to make a turn at the equator. This type of maneuver, by the way, is called a plane change. That's PLANE. Takes a lot of energy, or delta V, if you like. It's on par with the delta V required to put a heavier satellite into a much higher orbit. And the contract, it's a fixed price contract valued at $69 million to launch the COSY mission. And it's about a 37% increase in the price NASA paid SpaceX in 2019 for the launch of the similarly sized IXPE X-ray telescope into a similar orbit. But that rise in price is at least partially explained by inflation. So as we know, we need more of this type of satellite. So this is good news that it's going to launch on a Falcon 9. So where do we go from there? Where do we go from here? Happy 100th to Mars Odyssey. Mars Odyssey has made 100,000 orbits of the planet Mars. So many congratulations to NASA for that. When did it launch, Lou? Can you remember? It's been there quite a while, hasn't it? Hello? Can anybody hear me?
Sorry, had my mute on.
All right.
So let's see.
It's about 20 years, isn't it, Mars Odyssey? It must be.
Yes, it's been quite a while. 2001, I think.
Yeah.
Oh, wow, it's 23 years. Yeah, that sounds familiar.
April 7, 2001.
Well, NASA decided to celebrate it by the 100th orbit by taking a rather special image of Olympus Mons, the largest volcano in the solar system. And Olympus Mons, there we are. There's the image.
Oh, nice.
And that lovely image. Now you can see several sort of bands above the volcano. And that one is dust in the atmosphere. This one is a mixture of dust and water ice clouds. And this one shows the upper extremity of those water ice clouds. So lovely image from Mars Odyssey of Olympus Mons, the largest volcano in the solar system. And then finally, we've been talking about the Chang'e 6 rock sample or soil sample, if you like, that was returned from the far side of the moon by Chang'e 6. Remember that from last week? Well, there have been some unexpected finds about the contents of the Chang'e 5 sample that was returned from the near side of the moon. And there have been some interesting finds. Now, there were a few new minerals that hadn't been seen before. One of them is the most recent to be discovered. And because the spacecraft is called Chang'e, the new mineral has been called Chang'e Site. And it was discovered by researchers at the Beijing Research Institute of Uranium Geology, or BRIUG for short. And it's the 6th new lunar mineral to be found. It must have formed in the aftermath of an asteroid impact, one that likely left a crater anywhere from 1.9 miles to 20 miles across, depending on the impact angle. And a previous analysis pinned the age of the sample returned by Chang'e 5 at just under 2 billion years old. And it also contained a mix of previously known silica minerals, two called sapphire and stishovite. I don't know where they make these names up from. They also the result of an asteroid impact. But the biggest mystery was revealed late last week, that they found some graphene in the sample. Now, graphene, as you may know, is a single layer of carbon atoms arranged in a hexagonal lattice. It was not expected to be present on the moon's near side, at least, but they confirmed that there are a couple of layers of graphene and graphite carbon, and these may originate from mineral catalytic processes induced jointly by the solar wind and early volcanic eruptions on the moon, indicating, of course, that there's still such a lot about the history of the moon that we're simply unaware of. So there you have it. That's the news for this week, and I hope you enjoyed that.
Yeah, see, there's a business opportunity there for pencil makers if they go and mine the graphene on the moon. So
yeah, we should mention that this discovery of graphene could challenge the widely accepted formation of the moon theory, because it was supposed to be rather depleted in carbon in that model. So stay tuned.
Absolutely. Yeah. Yes, I mean, there's been a lot of hype about this, and you know, I've already seen headlines like, you know, presence of graphene invalidates our history of the moon and things like, you know how journalists just go over the top. But it does raise some interesting questions. As always, you're quite right. Okay, moving on now. Thank you for being with us up to now. We hope you enjoyed watching the belated launch of the Ariane 6 with us. It looks like everything's gone smoothly, and Europe is back in the satellite launching race with the new Ariane 6. So, Lou, would you like to talk to us about Voyager this evening?
I would always like to talk about Voyager. Very similar to something Carl Sagan said to me once at the Hawaiian airport. He said, I always have time to talk about Titan. But this is not about Titan. This is about Voyager. So do we have the presentation? Yeah.
I don't know. Hang on.
It appears to be loaded up on my screen. It appears.
Okay, just give me 1 second. 1 second, Lou.
Mm-hmm.
Okay.
And there we go. Okay. So some weeks ago, we reported that there had been problems with the Voyager 1 FDS, its flight data system, and it was sending back garbage. And then that happened in November. And the engineers and operators at Jet Propulsion Laboratory scrambled to find out what was wrong, diving into ancient users' guide that were in paper that were already yellowing, you know, at the Jet Propulsion Lab. The programming code for this for the FDS system was written in assembler with some Fortran, and oh my goodness, But they did it. And in May, they were able to execute a command that had the spacecraft returning science data for 2 of their instruments, right, for 2. So we have to go from a message of hope to back on track, or as we say in the United States, back in the saddle. So that was 2 of the fields and particles instruments that were sending back good data. And the 4 instruments study that are still operating on Voyager 1 study plasma waves and magnetic fields and particles. And the other 2 instruments required a little tweaking before they could get those going. But now we have all 4 instruments returning good data. And there's a little tweaking to be done. They're going to resynchronize a clock on board to make sure that commands are executed at the right time. They're going to do a little maintenance on the digital tape recorder, which records some data from the plasma wave instrument. Now, most of the instruments, the remaining instruments that are operating on Voyager, send data back directly to the Earth in what you might call real time, but the plasma wave instrument uses the tape recorder. Here's some, we were just talking about where is Voyager, how fast is it moving, and so on, and emphasizing the importance of multiplying by 3 when you do those calculations. These are, over 100, like 150 AU away from the Earth. They're only things that are in true deep interstellar space, still sending back data, and there's every reason to believe that they will stay operational until 2027, when we're going to have a big 50th year anniversary bash. Now, I wonder if I can share my screen here. Will that share over the presentation? Let's find out. Let's do an experiment.
Let's have a go.
Okay, it does. So, some of us are numbers people and some of us are visual people. And if you're a visual person, you can go to Eyes on the Solar System, the JPL immersive 3D modeling software that models everything in the solar system, from spacecraft to comets and asteroids and planets and moons. And you can just click on the Voyager Grand Tour and you can see where the Voyagers went. A little sped up, I admit. You can see Voyager 1 now going above the plane of the solar system. Here we see that. Voyager 2 going on to Uranus and Neptune. And it will run its course here fairly quickly until you find their actual positions outside the heliosphere in 2024.
I love Eyes on the Solar System. I visit it quite frequently. It's just there's so much fantastic information. Download it, viewers. Put it on your PC. You don't need the internet. You can download it, run it off your PC. And there's just a huge wealth of information about the solar system, spacecraft, exploring it. It's a wonderful free resource. Do make use of it because it's a lot of fun as well. So
double check that. I have downloaded it as well, but I think more recently they have gone to the web-based system. I don't know.
Oh, really?
I don't know running mine locally. But one way or the other, you can get to it.
Okay, I'm going to look that up straight away.
I know they did change something on that.
I'm still running it off my local machine, so.
I've got a funny feeling I deleted it off mine because it was, you can run it through the internet now. So
right, I'm just going to have a look to see. Well, it certainly is running in the browser, and there's no option there that I can see to download it. So yeah, all right, I take it back. It looks like you can only run it with a web connection. But anyway, however you run it, it's just a a valuable resource, and it's a lot of fun to experiment and play with. So thank you for that, Lou.
You bet.
Okay, right. Now, what I like to do, just out of interest, is ask all the panel and you viewers just one simple question. What do you think was the most interesting and unexpected result of the Voyager mission? Perhaps it's a single discovery or something more general. What was what for you stood out from the Voyager mission in terms of discovery? So let's ask Daz first of all. What about you, Daz?
Well, there were several. I mean, for a start, we got our first images of the close-up images of the outer planets, which was absolutely amazing. But I was also fascinated with when they actually left the solar system itself and went into interstellar space. The fact that it was so quite strange, because one minute they think, oh yeah, we've moved. Oh no, we haven't. Yes, we have. No, we haven't. And then all of a sudden it just dropped off, literally, oomph, and that was it. And it was the fact that it was just a complete cut off. Like I said, for a while, for quite a long while, is it, isn't it? And then it just went bump. So I was surprised at that. But I mean, I'd have to have a real good think about that, because there were so many brilliant events that it showed us, and imaging and things like that. So, okay,
all right, thank you, Michael. What about you?
I think it's got to be the volcanoes on Io, and the way they actually discovered the first one, with the plume on the Io's limb.
The first active volcanoes beyond the Earth. Yeah, absolutely. Roger, what about you?
He's muted.
You're muted, Roger. Let me unmute him. Hang on. Right, we can hear you, Roger. Can you hear us?
Yes.
Right. What about you?
I just enjoyed all the close-ups of the Jovian and Saturn moons that we've all become familiar with now, with all the other missions that have happened, and it's been fascinating on how much we've all gleaned and awed over to see all the fascinating surface details that we've seen since.
Okay. Okay. Derek says rings around the gas and the ice giants. Yep, absolutely. Amazing discoveries there. Anything else, viewers, you want to put forward as standout moments from Voyager for you? What about, we'll come to you finally, Lou. What about you? Or was it just everything?
Well, it was an experience without words, the time I spent on Voyager. But I'll go, if you don't mind, I'll just go planet by planet. For Jupiter, it was the discovery of the rings around Jupiter. We knew of the rings around the other gas giants before launch, but we didn't. Voyager discovered the rings. For Saturn, perhaps the braided nature of the F ring and the you might remember the ghostly fingers on the ring, which appear to be the spokes, levitated dust on top of the rings.
Yeah.
For Uranus, perhaps its tangled magnetic field. We knew about Uranus's funny tipped over orientation, but we never measured the magnetic field, and it is quite off axis with its rotation axis, and so everything's braided and crazy as the magnetic field goes out. And then for Neptune, I would say it would have to be cold ice geysers on Triton.
Oh yes,
just amazing. So
Ian says, of course, that famous image of the pale blue dot.
Oh yes,
yeah, of course, that's something else. But Ian's also put Pluto and Charon. Is he thinking of New Horizons?
That was New Horizons. Yeah. So
just
no less of monumental discoveries there, of course. Actually, this links with what I was going to say. On a more general note, I think one valuable lesson that came out of Voyager, if not the most valuable, was that the distant icy worlds of the solar system, in terms of planets and moons, and especially the moons, we didn't expect any activity there because of their distance from the sun. Yet virtually all of these worlds, or at least a lot of them, turned out to have activity. There's energy there. There's dynamic processes happening on worlds which you would, on first glance, assume to be frozen, lifeless, and dead. And I think that's a really valuable lesson that we learned from Voyager, that we shouldn't assume that because worlds are so far from their star that there's nothing going on. And as you mentioned, the ice geysers on Triton, completely unexpected. And at first it was difficult to believe that they were actually there. So it's a lesson that you don't need very much energy at all in terms of radiation from the sun to kindle and maintain these dynamic processes and these outer moons. And I think, for me, the moons were the star of the show with Voyager, without a doubt, because they were so incredibly varied. You had moons like Miranda, which looks as if it's been broken apart and joined back together again differently several times, at least in its history. That incredibly jumbled terrain of Miranda, that was a complete enigma, still is to a large extent. We don't know how on earth it got like that. And then you have got moons like Triton, intensely cold places. I think does Triton still hold the record for the coldest place in the solar system?
I think it does. The IRIS instrument looked at it, and because it was so cold, the data was rather noisy. But I think they were able to cap it at an upper limit of about 30 degrees Kelvin.
Nice. Yeah. So So anyway, for me, the moons were the star of the show, and this lesson that we learned, that they're not dead, frozen, or lifeless. There's activity there, and I think that was a valuable lesson. I think we all just expected ice balls, basically, with nothing happening, and that's not what we found at all.
I can tell you that apart from the moons, there was a lot of disappointment when we got to Uranus, because after the beautiful cloud structure on Jupiter and Saturn, we were hoping for something really dynamic, and Uranus was rather unimpressive, as we say, until you stretch the image and do some image processing. So it was felt that, okay, we're far from the solar system. You're not going to find much convection going on. Neptune is going to be a wash. And of course, it certainly was not a wash with its
no, that's right. That's right. Well, I mean, let's face it, Uranus is the most boring world in the solar system. It's like when you go to a party, there's a guy.
Don't tell Heidi Hamill. Don't tell her.
When you go to a party, there's a guy standing in the corner wearing a corduroy jacket and just wants to talk incessantly about football. That's Uranus. I mean, let's face it, even when Herschel discovered it, he reported it to the Royal Society as a comet because he couldn't believe that something so bland and featureless could possibly be a planet. He reported it as a comet because it was just so featureless and not uninteresting.
Really? So he was able to resolve the disk?
I believe so. Yeah.
Rather than wow. Okay.
Yeah. I might be wrong, but I think so. Yeah.
Derek says we have thunder in Liverpool, and Kev said, "Thunder in Liverpool, was that Voyager discovery?" I mean, is it sensors that good?
Yeah. And anyway, Ian, you're completely right. Voyager has kept the dream alive of life in the outer solar system. So there we are. It's a shame that we'll never see its like again, because humans in almost exactly 50 years completed the reconnaissance of the solar system, the initial reconnaissance. And I must stress this is only the initial reconnaissance. There will be other space missions, but nothing that just kept giving us planet after planet, moon after moon, like Voyager. And as I'm sure everybody here is so glad to have lived through those times. And just to plug yet again for the wonderful Irish film called The Farthest. If you haven't seen it, track it down, because it's an account of the whole Voyager project. And I think Lou would agree with me. It's the greatest documentary I've ever seen about Voyager. And,
it was thrilling. It was really it was wonderful.
Yeah.
And I think, by the way, I think it's 180 years since the launch of Voyager that we will have another planetary alignment similar to this, providing another opportunity for a Voyager-like mission. But
yes,
that's right.
Because there'll be humans living out in all those places. So there we are.
Yeah, well, I mean, as you say about the alignment, and that was what inspired this mission. But it was a case of that, they had to pull their fingers out to do it, because it was just suddenly, oh, hang about, what can we do for this? And then that's where the Voyagers came from. They saw this alignment and they said, well, we've got to do something. And it was done quite, and to actually work out the calculations on everything to make these happen. And then, of course, they had to sacrifice Voyager 2 for just so that they could visit
Voyager 1.
Voyager 1, sorry. It's just, but the whole thing was absolutely amazing. It's something that had never been tried before, never been envisaged, and lo and behold, they brought it all together.
Well, believe it or not, I still have a clipping from a comic I had as a child, but I wasn't bothered in the comic. There's just some great space articles in, and it's an article about what was then being called the Grand Tour.
Yeah.
So this was early 70s that they were contemplating the project because they knew about this alignment that only happens, every couple of hundred years. I've still got that clipping when they were calling it the Grand Tour.
And it was going to be a Grand Tour as well.
Yeah.
It was absolutely
apparently they had to do a little sneaky selling on this. I believe they sold it to Congress for a Jupiter-Saturn mission only.
That's right.
And in flight, they were able to get the funding to go on to Uranus and Neptune.
Yeah, absolutely.
Yeah.
So anyway, Lou, thank you for that look at Voyager. Please, as always, keep us updated on anything from the spacecraft. We always love hearing about it. And, it is humans' first interstellar spacecraft. So whatever happens to this planet over the next 100 years and the people on it, because we do face enormous challenges over the next 100 years, as everybody knows, our twin Voyager spacecraft will be sailing the seas between the stars.
They will be our legacy. That's right.
It'll be our legacy. Yeah, whatever happens to humans, the Voyagers will be our legacy until they just basically fall apart, which is going to take a long time. So we know that is it Voyager 1 is going to pass not that far from Sirius in about 46,000 years, if I remember rightly. So
not that far, but yes.
Yeah. Theoretically, they'll still be going for hundreds of thousands of years.
That's in my diary.
Yeah, and don't forget the golden disc that's on it, the record with the sights and sounds of Earth.
Yeah.
They reckon that could last 1 billion years, because there's no reason why it shouldn't.
Yeah.
Because it's made of metal and it should survive 1 billion years.
Long enough for record players to have a comeback. So
they were having a comeback. Yes, definitely.
Yeah. I mean, also
on the label about exactly how to play it. So any extraterrestrials who do pick the spacecraft up, if they're smart enough to do that, they'll work out how to play it.
Speak English.
Yeah,
absolutely. But the Pioneers have got plaques on them as well, haven't they?
Yes.
So that caused a bit of controversy, but there you go. We won't go into that. But so there's a few little things going out there that will show that we actually existed.
Yeah.
Absolutely.
So there we are. Voyager sails on into the void, and thank you very much, Lou, for keeping us up to date with it.
Yeah.
All right. Now we move on to Daz's solar watch. Daz, just give me a second.
Yeah. No worries, mate. No worries.
I just need to sort this out. Just talk amongst yourselves for just a little while.
Yeah.
I can still hear you, by the way. So
I was just wondering if Lou's got any more jokes.
Oh,
Okay. So no, it's like I say, with the Voyager, it's just one of those things that every time you think about it, there's a warm spot in your heart for them. they are
that's curry.
Possibly indigestion.
Yeah.
But no, the Voyager's always, as soon as you mention Voyager, you think that's the boy. The boys are out there, they're doing the stuff. And they're still doing it, as you said. It's a couple of years' time, we'll be cutting cakes and hoisting a glass of champagnini.
Yeah.
And
both Voyagers and Pioneers will just carry on going because of the laws of gravity.
Well, yeah. I mean, we don't know where they will end up in the end. But you know, it's just I'll have to have a look into one thing that just popped into my mind is the Elon Musk Roadster. When's that due back? That's coming back soon.
It's making a close, inverted commas, close approach to the Earth fairly soon, if I remember right.
Yeah, I'm going to say it'd be nice if we could get some images of that, see how that's standing up.
Yeah. All right then, Daz. There you go.
Right, okay then. So here we are. We're at the Sun review for 22nd of the 7th. Oh, that's the old one. Oh no. Well, somehow that should be 02.
Right.
On the 22nd, I thought, Gordon Bennett, we're in the future. I'm telling the future. So anyway, yeah. So here we are. Well, unfortunately, again, we've got a bit of a slow week, but there is some light on the horizon, and what we've got here is that, to make sure I've got the right one, as we said, we started. If you'd like to move on to the first slide, Andy. Right, this was last week. Well, actually, no, it wasn't last week. This was a couple of days before the second. And of course, this is when we had all of this action going on in the sun. This is why I put this one up. It was virtually the whole of the central disk was virtually covered with active regions and all that, although they weren't doing that much. If you can go to the next slide, Andy, please. This is... Oh, I've gone.
What's happened to your presentation? 1 second, please. There we are.
Yeah, so if we can go on to the next slide, Andy. So this is the sun today. As you can see, I seem to be on a very small screen here. So what we've got here is we're down to... I'm going to have to read this off my paperwork because I can't see what's on there. That seems to have gone small. So we're down to... where's the last page? We're down to 5 regions. The sunspots count at the moment is 90. The sunspots have dropped off dramatically because if you remember, we started with this week with 15, if I remember rightly. Because like I said, if you looked at that image I just showed you, there was active regions and sunspots everywhere. Now, what I would like you to take notice of, we've also, as you can see on the right-hand side, you can see we've got 2 coronal holes. Now, the coronal hole, I can't see the numbers on them now. I think it's number 51, which is down in the bottom right-hand corner. That is actually now more Earth directed. And remember, we're looking at this from the Solar Dynamic Orbiter observer, sorry, and this is its perspective, but it's actually more towards the center at the moment. So that's given us some enhanced solar winds. But you can also see there's a bigger and darker one up towards the top in the northern hemisphere, which possibly will rotate around and give us a bit more wind a bit later. But as I said, what I would like you to look at is on the left-hand image, is that there's 2 round dots which have no numbers. Now, this is a massive sunspot region that is coming into view. I've been watching it for the last week or so. So if you'd like to go on to the next screen, Andy. Oh, sorry, this is the week. What I've done is I've actually reduced these to 80 seconds now. But one thing that has fascinated me all week is this region. Oh, you can't see it because I'm not using my cursor. But the 8 o'clock region, you see that massive prominence. I've nicknamed it the lava lamp prominence, and it's been providing us with beautiful views all the time, virtually all the week. As it comes around, of course, we're getting to see less and less of it, but it's still there to this day. And if you look at images of today, if you know where to look, you can actually see it as a filament still there. But it was giving us some absolutely beautiful action. We've just got 3738 coming to view, more on the equator. But if you look behind it, you've got all this stuff that's all this glowing stuff and this eruptions and that going on. Now, this is the spot that's just coming into view. And I've been watching this, as I said, for the last week or so, just to see if it broke up. And what it is, it's two older spots, which I think are 3712 and 3713, which seem to have combined. And they have formed a very, very big spot. If you can go on to the next one, Andy, I think it's another image. This is in a different light. I'll be playing these again, but the last 48 hours, so you can actually see how this region on the east side is developed. At the moment, all the actions on the western side, as you can see, all the active regions are rotating out of sight. There's a few flares. There's quite a few filament lifts off CMEs, but they're all very minor. Nothing that's going to rattle our cage and give us a massive auroras or anything like that. So again, it's been a pretty slow week as regards that sort of thing. Now you can see on the eastern limb about the 8 o'clock, you can see all these magnetic arches, and they're absolutely beautiful. And there's more and more of them coming into sight. The spot on the equator is 3738. That again has got a very interesting magnetic configuration, so it could give us some bigger flares. But this, what is behind, was even yesterday or the day before, I'm just trying to think out of the day's work, it gave us 4 M-class flares. Now, of course, they're not the big ones, they're not the X ones, but of course they're beyond they're still on the far side of the actual sun. So they possibly were even bigger than we actually thought. So again, Andy, please. Now, this is what I meant I was tracking. The sunspot on the far side of the sun. And they're using solar seismology, or helioseismology, I think it's called. Now, you can see in the middle, you can see on the top left, there's a region and it's got 2 numbers with it, and that is 3712 and 3713. Now, you can see already here on the, what day we got the 3rd, you can see these have already appear to have joined together. And then as you follow it through, if you go to the right, you can see they've thickened, they've darkened, they've got bigger. Again, on the bottom left, you can see that it's just coming towards the eastern limb. And then the last one is today's image, and you can see it's just breaking over the actual edge of the limb. So basically what you're looking at is the orange region is the far side of the sun, and the grey regions are the Earth facing side. So this slowly moves across to the left, and you'll see all these sunspots come into view. And as you can see above the big spot, there is another spot that's also joining us. But again, this is already showing us quite a bit of activity, so hopefully it will come further into view, and it may give us a little bit of action. It's been good that we've had lots of solar flares, but they've all been down in the C-class flares mostly. But we are showing some low numbered M-class flares now. It's been, in a good way, it's been good for the sun to be silent, because with Hurricane Beryl creating havoc on the other side of the pond, one thing they didn't want is these flares going off and causing major radio blackouts while they're trying to assess damage for rescue missions and things like that, because you need your radios, you also need your GPS. So it's been helpful in that way, but it looks as that may come to an end in the next day or two. I think this big spot will take possibly another at least 24 hours before we got a full view. In fact, they're still determining whether or not it's one big spot or it's going to be 2 or 3. So that's something to look forward to. If we move on to the next one, Andy, this one again, this is the last 48 hours. They're only about 20 seconds long, but you can start to see the big event coming around the side there. We've also got 3738, which is already moved into, but you can see it coming in on the limb, and you can see it's actually firing stuff off. This is in another wavelength. This is 171 Armstrongs, and you can see it comes in. The arches are forming, and it's absolutely spectacular. You can see in the middle. There's a little green flag, and it's flashing all the time because this is minor flares that are going off. So we have been having the flares, but they're the lower end. So hopefully they haven't caused too much destruction. And finally, this is 131 Armstrongs, and you can see it's coming around. You can see all this stuff firing off from beyond the actual limb. So this will be coming into view soon. With, of course, just above 3738 there, you can see that coronal hole, that black spot. So if anything starts kicking off, then maybe we might be getting some auroras into some decent lower latitudes. So that's basically, so keep an eye on your aurora alerts. If I see anything, then I'll chuck it into, I'll try and put alerts out. But yeah, that's it. So it's been quiet. We may get something. I can't promise anything. But also it has been noted that the sunspots, the trend of the sunspots is now beginning to seem to drop a little bit. Whether or not it'll pick up again once these big regions come into view. And of course, this will have an effect on how we'd view the cycle 25 of the sunspot cycle. So there you go.
Fantastic. Thank you so much for that, Daz, as always. Where will we be without you, Daz, keeping us up to date with what's going on?
Probably awake.
Yeah, that's true. That's probably, yeah, in another life. No, as we approach solar maximum, this is going to be even more valuable each week to know what's going on.
What's else Kenneth just said? Sorry, excuse me. Is this tonight, Kenneth, you're talking about? And more to the point, where are you, Kenneth?
He's in Norway.
He's in Norway. Oh well, yeah, of course they.
Yeah, near
would.
Bergen.
He's had two 5 KP5s, so lucky him. But unfortunately, he says it's too cloudy and too bright skies, of course. So yeah, anger. It's always the way. These things are sent to try us, but
well,
just keep an eye out during the week.
Yeah,
we'll just turn that off.
Yeah.
It might be partly clear tomorrow, so I'm going to have a look at the sun tomorrow and see if I can spot anything. But if there are anything, I'll post them on the Facebook group.
Yeah, that looks a bit of an exciting, a huge area coming round just now. So watch this space.
Indeed. Anyway, thanks to all of you this evening. Time to wrap things up a little bit, I think, for the evening. Thank you to Roger. As always, thank you so much to Lou for keeping us up to date with Voyager. Keep us posted. Thank you to Michael for being here. For your contributions about Ariane. Thank you to Daz for your solar watch, and well, thank you to me, basically.
Yeah, and thank you to Rachel and Isaac for putting in.
Of course, and thank you for Rachel and Isaac for dropping in. Lovely to see you. Next week, I won't be here next week because I will be speaking to Macclesfield Astronomical Society about the wonderful subject of gravitational waves. So I won't be here, but the others here will hopefully keep the ship on course in my absence. So I will see you back here in 2 weeks. But, don't let it put you off watching the fact that I'm not here next week. We'll see how the viewing figures drop off when I'm not around. You just watch. Anyway, I shall miss you all, obviously. So I'll be back here in 2 weeks. But don't give the others a hard time in my absence. Treat them gently. And... we will, I won't, but the rest of you will see you next week. Thank you so much for being with us for the launch of the Ariane 6, the inaugural launch of Europe's new rocket. Sorry that we sort of missed the actual launch itself. We had a few gremlins here this evening for one reason or another.
It was completely out, yeah.
Yeah, but we're just lucky that we managed to get on the air at all, actually, in the end. So apologies for that. At least we got to watch it together anyway, and hope you enjoyed that. let's just have a final quick look at the launch schedule for the coming weeks. I don't think there's anything. Is there anything major coming up?
Only on the 31st, the Polaris, if I remember right, the main Polaris mission. So
yeah, let's just see if anything else has popped into the schedule. We've got a Falcon 9 mission on the 10th with Transporter 11. Those rideshare missions, including the ESA's Arctic weather satellite. There's a UK satellite launching, Surrey Satellite's Taiki satellite for the UK Space Command. There you are. Japanese satellite and a US-based Planet Labs Tanaga 1 satellite. So they're all launching together on a Falcon on July the 10th. July the 11th, another Starlink mission. There's an Atlas V launching for the US Space Force. Of course, undisclosed payload. That's
never a secret. Don't tell anyone.
No, don't tell anybody. We'd have to kill you. That's coming up sometime in July. The Polaris Dawn mission is still scheduled to happen. They're talking about the 31st of July. We will give you a full rundown on exactly what that's all about before then. And I think that's just about it. Except, no, that's it. That's it. So we still got... They're still saying the Dream Chaser launch is happening third quarter, but we now know, sadly, that the Dream Chaser mission, the first launch of this revolutionary new space plane, has been postponed until next year.
Oh, nice. I hadn't heard that.
Yeah, because of the necessity for ULA to get their act together to launch the military satellites that they're contracted to launch and they're well overdue with. So Dream Chaser's gone on the back burner a little bit, unfortunately.
And don't forget, we've still got to see Starliner come back.
Yes, indeed.
That's
the
still
astronauts are still absolutely not stranded on the ISS. Just put that in flashing neon. They're not stranded. NASA say they're not stranded. Boeing say they're not stranded. So they're not stranded. Of course, they're not stranded. There's no risk of them being stranded. They've got enough supplies to last for a long time. Move on, please. Nothing to see here, basically. They're in no danger. And Starliner's departure from the ISS, of course, has been delayed, as we know. But it will sort out, I'm sure.
I'm just wondering how long it can stay up there before it becomes a problem with docking, it blocking a docking point.
Yeah.
Well, we'll see what happens. But they're not in danger. No one's in danger.
They'll work it out. They're probably having a whale of a time. You know?
Yeah. I mean, Sunny couldn't wait to get back up there.
No, absolutely.
She was,
and I'm
ecstatic
sure
to get there. So yeah.
There we are. Thank you for being with us, viewers. Much appreciated from all of us at Space Oddities.
Yeah, thanks for your
kind to each other.
Yeah.
Beginning to sound like the guy from Mr. and Mrs. now. Be kind to each other. Be good to each other. Be good, and if you can't be good, be average. We'll see you next week. So from all of us at Space Oddities, thanks for your support, and bye-bye.
Be most excellent.
Be most excellent, says Daz.
Bye.
Like you would know, Daz. Yeah, right.